Good morning everyone. In the previous video we have discussed about the reduction process. To continue with the reduction process. Reduction of oxide ore. This is the third process. Reduction of oxide ore. Change of oxide ore into its metallic form. For example, if it is zinc oxide, we use, for reduction we use two terms, calcination and roasting. Conversion of oxide ore into carbonate ore into oxide ore is by calcination, and conversion of sulfide ore into oxide ore by roasting. After calcination and roasting, we use a reducing agent. For example, zinc oxide is reduced by carbon to form zinc plus carbon monoxide, or carbon dioxide as well. Another example is zinc oxide plus hydrogen. We can reduce zinc oxide by hydrogen? We can't, because zinc is more reactive than hydrogen, so hydrogen will not replace zinc from its oxide. We use copper oxide plus hydrogen, copper plus water. So carbon and hydrogen, here carbon and here hydrogen acts as a reducing agent. In the process of reduction, we need to reduce ferric oxide, and to reduce ferric oxide, it is in solid form. To reduce it with aluminium powder. Aluminium powder is also solid. When ferric oxide reacts with aluminium, iron we found it in liquid state. With the formation of aluminium oxide, the melting point of aluminium oxide is more than that of the iron. So iron here is found in the liquid state. This iron is used to repair railway tracks, etc. Because it is in liquid form, we can use it to repair railway tracks. A machine moves on the railway tracks, and where this reaction occurs, and we get iron in liquid form, and by this liquid we can repair railway tracks, etc. In this reaction, as you can see that iron oxide in solid state, aluminium in solid state forms iron in liquid state. Means this reaction is highly exothermic reaction. Heat is evolved in a large amount. Highly exothermic. This reaction is highly exothermic reaction. Highly exothermic reaction. So this reaction is termed as thermite reaction. Thermite reaction. This reaction is very important reaction for your exams. As what is thermite reaction? The reaction between solid aluminium powder with iron oxide to produce a large amount of heat, or to produce iron in its liquid form due to the evolution of large amount of heat. So this reaction is called thermite reaction. Therma means heat. It is related to the heat. So this reaction is thermite reaction. We can also use this reaction for reducing MnO2 plus aluminium. If we want to get the metal in its liquid form, we usually use this reaction. The reaction of that metal oxide with aluminium. Here aluminium acts as reducing agent. So in this case, manganese oxide and aluminium, manganese is in solid form, aluminium also in solid form, aluminium powder, and after reaction we get manganese in liquid form along with aluminium oxide with the evolution of large amount of heat. So when the question said that write the thermite reaction, you must write the thermite reaction of aluminium and iron oxide. To start this reaction, we use burning magnesium paper. Okay, this is completion of reduction process, reduction of zinc, reduction of oxide ore or reduction of metal oxide. Next is refining. Refining, the process of refining, the fourth process, the process of refining means here we discuss electrolytic refining. Electrolytic refining. In the process of electrolytic refining, we usually use electrodes and electrolytes. We need electrodes. Two electrodes is needed, cathode and anode. Cathode and anode. Cathode, which attracts cation, means it is negatively charged electrode and it is positively charged electrodes. So cathode and anode. At cathode we use pure or impure. We need to purify the metal, so we use cathode. At cathode we take pure metal or pure metal rod, a thin pure metal rod. And at anode we use impure metal rod. And this impure metal rod is naturally thick. A metal rod which we obtained after reduction is now refined by electrolytic process. We need two types of electrode, cathode and anode, and electrolyte. The electrolyte we use here is the metal of we can say that the compound of that metal which we use to refine. If we use copper, for example, if we use copper, if we want to purify copper, then we use copper sulfate solution. And this copper sulfate plus dilute sulfuric acid, some amount of dilute sulfuric acid. So the electrolyte we use is acidified metal salt solution. Acidified metal salt solution. So let's start the process. All of you note all these things in your copy. It is very important. So, purification of copper. To purify copper, we need two electrodes. The electrodes are made up of, if it is thin and this is thick, copper rod. thick copper rod, you must place it at anode, and thin copper rod is negative terminal. So add this positive and negative terminals. So this is pure copper rod and this is impure copper rod. We use an electrolyte. The electrolyte is, which electrolyte? It is acidified means acidified copper sulfate solution. Acidified means add sulfuric acid. Only sulfuric acid is added to it, because sulfuric acid is the only acid here which is non-volatile. HCl and HNO3 are highly volatile. So after passing the electric current, it evaporates. So when the electricity is passed, the copper here, it is copper sulfate solution. Due to this acidified copper sulfate, it becomes Cu2 plus and copper sulfate 2 minus. And the water used to mix the copper sulfate is distilled water. This solution is of distilled water plus copper sulfate, and then add some amount of sulfuric acid, like 20 ml of sulfuric acid in 250 ml of water. So acidified copper sulfate solution, this copper and copper sulfate breaks into Cu2 plus and SO4 2 minus. Cu2 plus now move towards the negative terminal, because it is positive, it moves towards the negative terminal, and copper, here copper is present, copper loses its 2 electron and comes to the solution for making bond with sulfate, but it, due to this the presence of electric current, it moved towards the negative terminal, and this copper sulfate rod becomes thicker and thicker. This copper sulfate rod becomes thicker and thicker. It becomes thicker and thicker. And the solution is completely dipped into the solution. ये जो ऊपर है ये ऊपर नहीं रहेगा, पूरा अंदर चला जाएगा. Dipped into the solution. And the copper rod, this copper rod becomes thicker, and this becomes thinner and thinner and thinner. At last, a thin copper rod here, and here some deposition of impurities. Here, due to the impurities falls here, and at the impurities fall towards the anode, and so these impurities are called anode mud. And what is anode mud? Anode mud is the impurity present in the rod of the impure metal. So this is the whole process. I repeat. A thick rod of impure copper is taken as anode, and thin rod of copper is taken as cathode. And when electricity is passed through these electrodes, copper sulfate breaks and copper moves towards the thin layer or towards the cathode. And when after some time, if this rod becomes thicker and this becomes thinner. Now, reaction at cathode and reaction at anode. First, reaction at cathode. Reaction at cathode. This copper 2 plus gains 2 electrons, where here the density of electron is more, it is negative, due to high density of electron. So copper with 2 electrons and becomes copper. And reaction at anode. Reaction at anode. Copper, this is copper, when loses 2 electrons, it becomes 2 plus. It loses 2 electrons and it becomes 2 plus. So the whole reaction is copper becomes copper. Copper 2 plus, copper 2 minus. Here copper 2 plus added to the copper, and here copper loses 2 electrons. So this is the whole process of purification. In your question, there are this is of 3 marks question. Purification by electrolytic refining. Explain the process of electrolytic refining of copper by copper sulfate solution. You must add, you explain the reaction in brief. The electrodes, write electrodes, cathode, at cathode, thin copper rod, at anode, thick copper rod is present. In electrolyte, acidified copper sulfate solution is taken. After passing electric current, thin layer becomes thicker, and due to these reactions, reaction at cathode is this and reaction at anode is this. And this is the complete purification of copper rod. Likewise, as you purify copper, you can also purify zinc by, if it is purification of zinc, what you have to do? Cathode, which rod you take at cathode and which rod you take as anode. Here cathode, pure zinc rod, which is thin, and at anode impure zinc is taken, thick rod of zinc is taken. And electrolyte, which electrolyte you use? Electrolyte for zinc is acidified zinc sulfate, and reaction at cathode, like this, zinc 2 plus, by gaining 2 electrons it becomes zinc, and at anode zinc, this zinc loses 2 electrons and becomes zinc 2 plus 2 electrons. So this is purification of zinc. Likewise, you can purify silver. The pure silver rod is taken as cathode and impure silver rod is taken as anode. Electrolyte is not always sulfate. The electrolyte in pure silver, for silver, Ag. Pure silver, impure silver, acidified silver nitrate, or at cathode and at anode the reactions are, if it is silver, then silver plus is formed. By taking 1 electron it becomes silver, and at anode silver loses 1 electron and becomes silver plus and E minus. This silver moves towards the cathode. By gaining this electron, it becomes silver. This is the purification process of silver. Copper, zinc, silver can be purified by these processes. And next is how do you purify, or how do you, it means this is electrolytic process of, this is not refining now, this is electrolytic process of extraction. This is used for sodium chloride. What we have to do? Sodium chloride. Now, first make sodium chloride solid into sodium chloride liquid. By melting sodium chloride at its melting point, it becomes liquid. Then this sodium chloride, when pass electricity to this sodium chloride, electric current is passed through it, and this sodium becomes sodium and chlorine is separated out. Sodium, solid sodium and chlorine as gas. In this process we use sodium amalgam. In this process we use mercury to deposit sodium on it. So in this process we use sodium amalgam. Sodium amalgam. What is sodium amalgam? It is amalgam means mercury. It is related to the mercury. A solution of sodium over mercury. So at cathode the reaction is, it is only for your competitive exams. What is sodium amalgam? It is sodium amalgam NaNH3. At cathode, what reaction occurs? Sodium plus gains one electron and becomes sodium. At anode, chlorine loses Cl minus, loses one electron and becomes Cl. 2 Cl minus. Practice this reaction. 2 Cl minus now becomes Cl2 by losing 2 electrons. This is the whole process of electrolytic process of extraction of sodium chloride. Sodium chloride, potassium chloride, sodium oxide can be extracted by the process of electrolysis accordingly. In the next class, we will discuss about the corrosion and prevention from corrosion, etc. Thank you.